In this video, we're going to look at how to work out ionic formulas, and to do that you need to know the charges of some of the common ions, and you don't have to worry about memorising these. They're on the opposite side of the data sheet of where the periodic table is in the exam. You'll always be given that, okay? So let's have a look at a nice simple one. So if we wanted to work out the formula for calcium chloride, okay, on the data sheet it will tell you that calcium has a 2+ charge and chlorine, the chloride ion, has a 1- charge. So what would be the ratio of these ions when they come together to form a compound? Well, the easiest way of doing that is something which I call the crossing over rule, okay? And how that would work is, if you write down calcium and we want to know what number to put after the calcium, you take the number from here. So this is a number 1 here, so that goes down to here. Obviously you don't have to write a 1 because you've already wrote Ca. Then you're going to put in your Cl, and how many of them do we need? Well, the number 2 is there, and that number would go there. Now, the laws of chemistry aren't based on this crossing over rule. The reason why this works is because compounds, just like elements, are electronically neutral. So the calcium has a 2+ charge, the chloride has a 1-, so we need 2 chloride ions to cancel out that 2+ charge on the calcium, okay? Let's look at another example. If we wanted to do sodium oxide, okay? Again, using your data sheet, sodium is a 1+ ion, oxygen is a 2- ion, and we can follow the same rule again, will help you. We write down Na. What number would we put after the Na? Well, we take the 2 from here, so we've got Na2, and then we'd write oxygen, okay? What number would we put from here? So obviously this is a 1, so we don't have to write the 1, we're okay just writing the letter. So the formula for sodium oxide is Na2O, okay? And again, same thing again, oxygen is 2-, therefore we need 2 sodium ions, because sodium's only 1+, we need 2 of them to cancel that out. Let's look at another one, aluminium oxide. If we look at aluminium oxide, aluminium is 3+, oxygen is 2-. We employ the same rule again. We want to know how many aluminiums we need. We take the number from here and it goes over to here. So we've got 2 aluminium, and then we do exactly the same for the oxygen and it goes over to there. So we end up with the formula Al2O3. Okay. We're going to do 2 more. The next one we're going to do is aluminium nitrate. Okay, aluminium, as we said earlier, is still a 3+ ion, okay? And the nitrate ion is NO3-. So we're going to follow the same rule as we did before. So aluminium, we write that down, and the number we put here would be from here. So this is a number 1. So we don't have to put the number 1, remember, because we've written our Al. Then we're going to write down the NO3. So how many nitrate ions do we need? Well, the number here is 3, so that's going to go to here. So we need 3 of these. Now, to do this, we need to put a bracket round it, okay, to show the 3 like that. Because if we didn't, what we would have is NO3 and then another 3, which is, it looks like NO33, which obviously does not exist, okay? So the reason why we put the brackets in is because we're trying to show that there's 3 nitrate ions required, okay? So 3 of everything in the brackets, which makes sense because the nitrate is a 1- ion, aluminium is 3+, so we need 3 nitrate ions to counteract that positive 3+ charge of the aluminium. The last one I'm going to do is an exception to the rule, okay? Magnesium oxide. Now, the only time this crossing over rule doesn't work is when we have a situation where the charges are the same on both, okay? If we use the crossing over rule on this one, we would end up with Mg, we would have a number 2 here, and you do the same with the oxygen, okay, and you'd have the formula Mg2O2. Now that is not correct, okay? The only time the crossing over rule doesn't work is when the charges have the same numbers, okay? Because really MgO2 can cancel down, okay, to really just being MgO, which sort of makes sense. It should be a 1-to-1 ratio, because how many oxygens do you need to cancel out the 2+ charge of the magnesium? Well, you only need 1, because the charge of magnesium is 2-. So the only time this crossing over rule won't work for you is when they're the same charge, and then all you have to do then is remember they would cancel down to a 1-to-1 ratio. Hope you found this video useful. Thank you.